Hey, welcome back. In this video, we're going to talk about header files. Now, we've included header files, but we still haven't created our own yet. We'll discuss how header files allow us to have a separate file for each class, allowing us to keep our code more orderly. We'll then talk about a special type of function for classes called the constructor. Let's get started. Now, we've created a class in main.cpp called character. And then inside of the main function, we created an instance of the character type called knight. Now, if we wanted to, we could continue creating new classes inside of this source file, but our file would get very large very quickly. Now, it would be better to have each class defined in its own header, and that way, if we need to use a particular class, we could include the header for that class, and that way, we're only including the code that we need. Here's how it's normally done. A header file for a class is created. In the header file, the class and its functions and variables are declared. Then we create a source file for this class with the same name, only it has the CPP extension. In the source file, we define all the functions that belong to the class declared in the header. Now, for the class name to be defined, we must include the header file in the CPP file. One of the reasons why we declare the functions and variables in the header files and define them in the source files is because as our programs get large, we may need to include lots of header files, and if those header files contained all of the definitions, compile times would get very high. So let's create our own header file and CPP file for the character class. Okay, here we are in Visual Studio. Now we're going to create a new file, so we'll go to File, New File, and we'll save this file, so File, Save As, and we're going to call this character.h. Go ahead and hit Save, and now we have a header for the character class. Let's also create the source file, so let's go to File, New File, and then File, Save As, and we'll call this one character.cpp, and save. Now we can move our character class into its own header file. So here in the main source file, we can highlight the definition of the character class. Let's copy that with Control-C, and then here in character.h, we'll paste it in. Now notice we get errors for the Vector2 and Texture2D types. That's because these are defined in raylib. So let's go ahead and include raylib up here at the top. Include raylib.h. Now we can provide the implementation or definitions of the functions of this class in character.cpp. The first thing we need to do in character.cpp is include the character header. So include character.h. Now here in character.h, we have three functions. Now getWorldPause is defined here in the class, but setScreenPause and tick are defined outside the class. So let's go to the main source file and scroll down to those definitions. Here we have setScreenPause and tick. Let's go ahead and highlight those, copy them, and back in character.cpp, we'll paste them in here. Now we're seeing the functions for the vector operations have red under them, and that's because those are in the raymath header, so we need to include raymath. So include raymath.h. Now we can remove the character class from the main source file. Now if you hover over to the left of the class keyword, you get a down arrow and you can click that, and now the character class has been compacted onto a single line. We can do that with these two functions that belong to the character class as well. This makes it easier to highlight these and delete them. So now the character is no longer defined in the main source file, but we're still using the character type, which means we need to include the character header file. So let's include character.h. Now character will be defined. Now there's a special type of function that belongs to a class. It's called the constructor. The constructor is a function that has the same name as the class, and it has no return type. The constructor gets called whenever you create or construct a new instance of a class type. The constructor gets called when an instance of the class gets created. It's typically a place to enforce what's known as class invariants, or things that should never change, when it comes to a class. For example, in the character class, we have a texture 2D called texture, and we've used braced initialization to make sure that this texture variable is initialized. Likewise, we have an integer called max frames, and this is the number of sprites in the sprite sheet. Well, we've seen that we often take our texture and get its width and divide by 6 to get the width of a single sprite from the sprite sheet. That width is something that will never change throughout the lifetime of the program, so rather than calculating it multiple times, we can calculate this in the constructor. So here we have our character's constructor in the source file. Now, because texture and max frames are initialized, we can calculate width using texture and max frames. Here we see that we're setting width equal to the value of texture.width divided by max frames. Here we can also set the value of height equal to texture.height. We don't expect these values to change throughout the lifetime of the class. The constructor is a good spot to make these calculations, provided that texture and max frames are initialized before we do so. So your challenge is to create the constructor for the character class. Declare it in the character class in the public section and define it in character.cpp by fully qualifying the function name with the class name and the scope resolution operator. Create float variables width and height. Declare these in a private section in the character class in character.h using braced initialization. Then calculate width and height in the constructor. Use the values texture.width, max frames, and texture.height to set these values. Pause the video and do this now. So here we are in character.h, and we're ready to declare the constructor. We'll do so here in the public section. So we'll say character, and now we can define this in character.cpp. Up here at the top, we'll use the fully qualified name of the character constructor. And now we have our constructor definition. Let's create those floats called width and height, and we'll place them down here in the private section. So we'll have a float called width and a float called height. Now before we continue, I'm going to remove const from these three variables. Const variables in a class prevent some more advanced things such as copy assignment and move semantics. These topics are outside the scope of this course, but you can read up on them if you're interested. Now to set the values of width and height, let's go to character.cpp, and here in the constructor, we're going to set width equal to texture.width divided by max frames. And we're going to set height equal to texture.height. So now we have the values of width and height, and these can be used in the class now instead of calculating texture.width every time we need the width of the texture. So notice in set screen pause, we're getting the texture width and dividing by 6 here. We can take this whole quantity and instead use our member width. And we're also using texture.height. Instead, we can use our member variable height. Now we're also getting texture and dividing by 6 when we draw the character in the tick function. You'll see in our source and dest rectangles, we're using texture.width divided by 6. Let's go ahead and use width here. We're using it here, so we'll use width here as well. And here we're using texture.height, we can just use height. Now here in dest, we're using texture.width divided by 6. We're just going to use width. And here's texture.height, we're going to use height. Now our code looks a bit more readable and less confusing. So in summary, we learned about header files and how we can create our own header files and put our character class into its own header and source file. We created the constructor for the character class and calculated the width and the height in the constructor. Great job! I'll see you in the next video.